So we have our problem where we have alpha is an angle in quadrant 1, given information, quadrant 1, and beta is an angle in quadrant 4, so I'm going to strongly recommend that you draw them in the correct quadrants. And we can see that angle beta will have a third side length of +3. So if I want to do the sine of alpha plus beta, I'm going to write out my formula. Sine, cosine, cosine, sine, alpha, beta, and in the sine formula, when there's a plus between the two angles, there's a plus in the formula. So now I'm going to copy all this information from my triangles. I'm going to say the sine of alpha is 2 root 5 over 5. The cosine of beta is 3 over 5. The cosine of alpha is root 5 over 5, and the sine of beta is negative 4 over 5. So I'm going to get 6 root 5 over 25 minus 4 root 5 over 25. So that's going to leave me with 2 root 5 over 25, and that's the answer to what is the sine of the sum of these two angles. I never did need to figure out what the angle was in order to be able to figure out the sine of the sum of the two angles. So we're going to establish some identities also, and that's going to be a matter of using these formulas. So I'm going to let you work on those. And then let's work on the sum and difference formulas involving inverse trig functions, because those can be tricky. So what you need to realize is that if I write sine inverse of root 3 over 2, that's an angle. Cosine inverse of 1, that's an angle. So in fact, let me write out alpha is the sine inverse of root 3 over 2. And beta is the cosine inverse of 1. So in this case, we can see what the angles are. In the next one, we're not going to be able to tell. But let's go ahead and see that this one we could evaluate first. So we know that if alpha is the sine inverse of root 3 over 2, then sine of alpha is root 3 over 2. So we need to think about what angle in quadrant 1 or 4 has a sine of root 3 over 2. Well, that's going to be pi over 3. So this equals the sine of pi over 3 plus the inverse cosine of 1, we think, well, what angle has a cosine of 1? Oh, that's going to be 0. So this is really asking us what's the sine of pi over 3, and so we're going to get root 3 over 2. The next one's a little more work. So the next one we have that alpha is the inverse tangent of 5/12, and beta is the inverse sine of negative 3/5. So we know by the way the inverse trig functions are defined that alpha must be in quadrant 1. So I have an angle that has a tangent of 5/12. So let's see, 144 minus 25. Wow, this is ugly. That's square root of 119, it looks like. I'll double check that. And then beta, where's the sign negative, considering the restricted domain, needs to be in quadrant 4, and I have an angle with a sine of 3/5. And the 3 is negative, and the third side length is going to be a 4 for a 3, 4, 5 right triangle. So cosine of a sum of two angles is going to be cosine, cosine, sine, sine, alpha, beta, alpha, beta. In the cosine sum or difference, if you have a minus in the argument, you have a plus in the formula. So let's go ahead and write cosine of alpha, which is going to be 12. What was I thinking? This is 144 plus, so 169, so this is 13, 5, 12, 13. I knew that didn't seem right. So we're going to have cosine is 12 over 13. This is alpha. Cosine of beta is positive 4/5 plus sine of alpha is going to be 5/13, and sine of beta is going to be negative 3/5. So we're going to have 48/65 minus 15/65, so 33/65, and that's going to be your answer. So for this next one, I would have alpha be the inverse sine of negative 4/5. So draw a picture and have negative 4/5, so your third side length is 3. And beta is going to be an angle with a tangent of 3/4, so 3, 4, 5 triangle, and then plug into the formula. And that's all we have.